Alright, I've got a graph of a function here. Um, don't ask me for the equation for this function. I just I just drew it onto here. It's a function of distance with respect to time. So distance as a function of time. So here would be where the distance would be 0. After 1 second, whatever this is uh, over 50 meters away from the starting point. After 6 seconds, it's 133 or so meters away from the starting point. And maybe it's the graph of the height of a UFO. It lifted off the ground and crashed or something. I don't know. And what we want to do is we want to practice identifying over what intervals is the function increasing, over what intervals is it decreasing, over what intervals is it constant. And if you can nail this skill, this will really help you in calculus down the line. Um, Increasing, decreasing, and constant. So a function is increasing if y increases as x increases. So okay, so this goes back to the concept of slope. This is so elemental to everything. Slope is the change in y over change in x, the ratio of how quickly y is changing versus how quickly x is changing. So a positive slope, the part of a function that would have a positive slope is an interval in which the function is increasing. Okay, so a function is increasing if y increases as x increases, or as the output variable increases as the input variable increases. So um, in in this direction, x is increasing. So as the function moves this way, if the y values are getting bigger and bigger, it's an increasing um, function, or that interval. The function is increasing over the interval. A function is decreasing if the output value, what you'd plot on the y-axis, is decreasing as x increases. So x is going increasing that way. So if the y values are getting smaller and smaller, then it'd be decreasing. If you can think of it, it has a negative slope. And then a function is constant if as y is or as x is increasing, the y values stay the same. They remain constant. So let's practice just splitting this thing up into intervals. An interval of time, or an interval of the domain of a function, is just a subset of the whole domain. So, a section of it. Um, for example, like an interval of time could be 1 second, could be 10 seconds, a 10-second interval, a 5-second interval. All right, so I'm just going to um, split this function up into intervals that look um, kind of like they're doing similar things. All right, so like this region here, um, could say from 0 to 3 looks like a distinct interval where the graph has a certain kind of behavior, and then uh, I'm gonna kind of create another interval there if it'll let me do that. Um, there, let's see, and then I'll create one there, and I'll describe what I'm doing, or what I have done after I create these intervals. Um, and then I'll try to explain, what does that mean as far as the real world behavior that this function is modeling. Uh, okay, so there's to me kind of the natural breaks in this function, where it's kind of interesting to talk about the behavior of that function. So the interval from 0 to 3 seconds here, in that interval the function is increasing because as I'm getting larger and larger x values, as the time is going on, my y values are increasing. And in fact, they increase very quickly. After 1 second, um, the spaceship is already 60 meters above the ground. After 2 seconds, it's 100 meters above the ground. This is a very fast rate of change of distance or height. Um, so the slope on this section of the graph is very steep, right? It's a very, very large change in y versus a small change in x. So it's increasing. And then over this interval from about 3 seconds to about 5 and a quarter seconds, let's say, maybe I'll just make it even 5. Why not? Might as well just make this an even 8. So from the interval from 3 to 5 seconds, it's still increasing. The function is still increasing. I'm still getting larger and larger y values as my x values get bigger, but it's increasing at a slower rate, right? So if I were actually to graph the rate of change of this graph, then this interval would of the rate of change graph would actually be decreasing. But that's, think about that, meditate on that, and then really get into that in calculus. In other words, well, but just to interpret this in real world terms, here, oops, sorry. My velocity is very steep, very high velocity, but then I'm slowing down. I'm slowing down, slowing down. So the rate of change in my velocity, i.e., my acceleration, is negative. I'm going slower and slower. Okay, anyway, kind of getting off on a tangent. Let's look at this interval. The interval from 5 to 8 seconds. With the exception of right there, it's basically a constant interval. So as x gets bigger, I'm really kind of hovering at 100. Y is like 133, 34, or something like that meters, right? So I would say, in real world terms, if we're talking about a spaceship or something hovering above the Earth, it's actually like literally hovering. It's it's just staying at a constant 130 something meters above the ground, and then time is passing. All right, for this interval, sort of we're not hovering anymore. We've got an increasing interval, so the distance is increasing as x increases, and then all of a sudden, we've got this dramatic shift downward, where as my x values are getting larger, i.e., as time is passing, the distance is decreasing dramatically. So this is a decreasing interval right here, and it's decreasing very quickly. So over the span of just 1.5 seconds, the thing goes from about 140 meters to 50 something meters. Very, very rapid decrease in distance. Distance above the ground or whatever we're talking about. And then the graph bottoms out and begins to increase again. This is an interval in which the function is increasing. And then, if you take, again, don't really worry about this until calculus, but just a little side note. If you look at the line tangent to that, where the spaceship changes direction, it goes from descending very quickly to ascending very quickly. If I were able to create an interval of the function that would be infinitely small, over that interval, the function would be constant, right? Anyway, you'll get into that. And then so we have an increasing interval in which the function's increasing, and then an interval in which the function is decreasing, and then presumably the thing hits the ground or something here. All right, so increasing, decreasing, and constant intervals. I challenge you to really think about if it's a graph of something in the real world like distance versus time. Think about interpret the meaning of the fact that it's increasing over a certain interval and decreasing over a certain interval, and uh, about what if it's increasing at a very rapid rate or increasing at a slower rate? What does that mean?